Hi everybody. So today's lesson is about force and acceleration, and this follows really nicely from the last lesson. So what we've learned so far in the first two lessons, the first lesson was an introduction to forces and about the types of forces, and the second lesson was to do with force components. And what we looked at was if something is moving, then we need to use the force component in the direction of motion. Now, we've learned last year about Newton's laws of motion, and we've also learned when forces acting on an object are not balanced, there is a leftover force. This leftover force is called the resultant force. It's also called the unbalanced force. Now, when there is an unbalanced force acting on an object, what happens is that the object will accelerate. Now, acceleration could mean changing speed, or it could mean changing direction. Okay, now the thing is, the direction of the acceleration is always in the same direction as the unbalanced force. So that's an important thing to remember. These two directions are the same. Okay, so I'll write some notes for you, and I will put a photo of my notes on Google Classroom, but I'm sure if you've just listened to me, you've understood what I've said so far. Now, what part of today's lesson is solving problems on force and acceleration. So it's these questions here, and I'll work through question 1 with you, and I'll work through the others and take a photo of that and put that up. I might also talk you through a later question in a separate video. But this is just question 1, and you'll see how easy it is. There's just one little thing that you add to it, and that's the formula using F equals ma that relates the unbalanced force, mass, and acceleration. So here's the first question. A sledge of mass 5 kilograms. So I'm just going to write the mass of the sledge. So this is question 1. The mass of the sledge is 5 kilograms. Is accelerated on an icy surface. Now, the moment the word icy comes, it means that there is no friction. Okay, and it is accelerated by pulling on a rope attached to its front end. Now, if the rope was horizontal, that means parallel to the ground, you would be using all the force that you apply to accelerate the sledge. But if the rope is at an angle, then the component of the force in the direction of motion is used to accelerate the sledge. Okay, so that's where these questions in year 12 are different from what you did in year 11. Now, the tension in the rope is 8 newtons, and the rope makes an angle of 20 degrees with the ground. So let me just draw the diagram. So there's your ground, there's your sledge, 5 kilograms, and here is the rope that's being pulled, and the tension in the rope is 8 newtons, and this angle that it makes is 20 degrees to the ground. So there's your scenario. Okay, calculate the force component acting on the sledge along the icy surface. So what they're really asking you is the horizontal component of the force here, because the sledge is moving horizontally, and the horizontal component is 8 cos 20. So if I put that in my calculator, 8 cos 20 gives me 7.51. Okay, so that's what I get. Okay, so that's the force in the direction of motion. Use F unbalanced equals ma to calculate the acceleration of the sledge. So F unbalanced equals ma, and we've got to calculate acceleration. Now, the unbalanced force is 7.51 equals, the mass is 5 times a, or a is 7.51 divided by 5, or your acceleration is the 7.51 divided by 5 will give me 1.5 newtons. Sorry, 1.5 meters per second squared. Okay, That's a unit for acceleration, meters per second squared. I hope you can see the red. It gets a little faint. Okay, explain why it is necessary to use a component of the tension force to calculate acceleration. So this is what I said in the beginning. It is only a part of the tension force in the horizontal direction that causes acceleration, because the sledge is moving horizontally, so only the horizontal component will give it acceleration. What does the vertical component do? It's not us, but the vertical component is going to try and lift it up. Okay, so that's the answer to question 1. I'll work the others through, take a photo and put it up on Google Classroom. And I hope you'll be able to complete most of these questions. Okay, bye for now.